One, two, three. I breathe and say that. We're sorry you're homesick, and we wish you could be here with us. We're all excited because we're going to learn about exponents and roots this chapter. Ooh, excitement, right? Yeah. Their enthusiasm is overwhelming. Okay, moving onward with that one. We are starting a whole new unit. You have now finished all things squared. We're done with everything quadratic, and we're now ready to move on to every other possible exponent there is.
Wait, who are you graphing?
Little. One day we graph a little. What is wrong with graphing? We have to learn how to graph Scrabblers this time. Yeah. So names my students, not an official math name. But we'll get to that. However, you need to understand this particular chapter. The first part of this is going to be a review of Algebra 1, how you work with exponents, and we're going to have more. This chapter itself isn't usually that tricky, and I've occasionally had people have a tendency to blow it off. I can't imagine. But the next chapter is the exponential and logarithm chapter. Logarithm. Okay, you have to be able to use what you learn in this chapter to use the next chapter. So if you don't learn this chapter, it's going to make logs, which are a bit challenging on their own, way more difficult if you don't know how to work with exponents and roots. The two mesh together. So doing one's homework is a valuable thing. All right. So today we're just strictly rules of exponents and a little bit of scientific notation. You'll notice on the bottom of your journal, on the bottom of the front page, it says list of 6 rules of exponents. I'm only teaching you 5 of them today. We don't get number 6 until Friday. Don't panic when you don't have 6 of them right now. So we need to do a little bit of check on terminology here. What? These problems don't take much at all. At the moment, I just want to talk, terms. What do you call the number? The number in front of the variable is, that is the coefficient. Okay. What's the technical name for the 5 that's raised up there? That's your exponent. Okay, x is a variable, but when it's under an exponent, it has a name. I don't need a time check every minute, thank you. Particularly if I wrote, say, 2 to the 5th power, what's the 2? What's something that's under the exponent? There's a name for it. Starts with a B. The base. There we go. Somebody got it. Yes. We will spend a lot of time worrying about what's the base under our exponent. That's a big deal to us, particularly when we start working with bases in our numbers. Okay, so since you seem to know that, let's double check a couple other things here. How do you know when you are allowed to add quantities that have variables?
Same coefficient. I meant that.
If the terms have the same variables with same exponents, everything has to be identical. You can add the what? You add the coefficient. Do you change the variables or the exponent? No. It's called adding like terms. Are we familiar with adding like terms? So and here I'm doing exactly what I was not wanting you to do. So, you'd say 8x squared y to the 5th. You simply add the coefficients, don't change the variables. Okay, that should not be a big surprise to you. Been there, done that. So, rule number 1, here we come. This is what's going to go on whatever it is on your journal, the bottom of your journal. Okay. The rule itself is very short. I'm going to put the rule right here in a second, but I want to give an example first, and then we'll turn it into a rule. How do you take x cubed times x to the fourth? What do you get?
Add the exponents together.
You add the exponents, so I would get x to the 7. Why? Why does that work? What does it mean to cube something? Yeah, so it means we have 1, 2, 3 x's times themselves, and then over here I would have 4 of them times themselves. And yes, then they add together, maybe, except it just froze on me. The palm did not freeze, though. Okay. You didn't get a pause. I know, it won't work. I have a pause over here. It's still there. We're back after a freeze up. Hello. So, as I was trying to write here, if you've got 3 x's times 4 x's, how many do you end up with? 7. You end up with 7. Okay. So the general rule is if you have a to the m power, some base to the m power, times a base to the n power, okay, you all realize all they can hear is all that gobbledygook on this audio if you're talking back there. So it becomes a to the what? Mn would say am I multiplying it?
That would be 2am.
Thank you, m plus n. A plus weird. So notice there is a base underneath both exponents. When each one has its own base, you're going to add those exponents. So that was a little basic. Y'all are wanting a bigger challenge, I can tell. So let's do something with a little more pizzazz here. If in this case I told you to multiply those two expressions together, that would be a to the 5th, all right, b to the, there we go, b to the 7th, c to the 13th, because we simply added our exponents. Woo, blew you away on that one.
We learn the opposite way.
Okay, here's where I cannot get people to keep this straight. So we'll see how, they got it this morning, I was pretty impressed. When I say take 7 cubed times 7 squared, the question is it 7 to the 5th or 49 to the 5th? 49 to the 5th. What do y'all think?
7 to the 5th. You don't solve it until all the exponents are together.
Okay, Michaela said you're taking 7 times itself 5 times. Yeah.
That was wrong.
And up here, if you look at the rule, even though, I mean, they use the letter A as the base, but is it saying you change that base when you multiply? No, they keep the A the same. You never change the base when you're working with exponents. Never, ever, 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 ever change the base. In fact, this morning I made the point with never, ever, 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 ever change your base. Okay? Did we get that point? So, that's not very bright.
It was fluorescent like.
No, it's not. It's not good enough for this point.
Never. Whatever that.
That's an H.
Never change. Never change. So it's the opposite of what one.
It even merits the picture pin.
Cherry.
Never change the base. Never, never, never. And when we're tempted, I never have troubles. If it's a variable base, nobody ever changes it. They get a number down here in the base, and they think they can change it. So, if I said to you multiply 2 to the 5th times 3 to the 3rd times 2 to the 2nd times 3 to the 3rd. Actually, that was 3 to the 2nd. The first one, sorry. Okay, I told you to multiply those. Okay, I got a 2 to the 7th times 3 to the 5th. Are y'all buying that?
Yeah.
Okay. In this case, where those are fairly big powers, I would be okay with you leaving the answer that way. Sometimes, though, they will go ahead and take it on out. My general rule of thumb is if it has a power of 6 or less, work it out to a number. If it is a power over 6, just leave it as the exponent. In this particular case, though, it's really not that terrible to work out because 2 to the 7th is only 128, and 3 to the 5th is only 343. And this is very easy on a calculator because it then comes out to be 31,104 if you really want to know. I didn't multiply that last one in my head. Okay. I cheated. It's on the picture. So, that's rule number 1. You ready for another one? Oh, we can get... Alright, rule number 2. You have seen this one before as well, but I'll give you an example first. If I gave you k cubed to the 4th power, what do you do when I have a power?
Multiply 3 by 4.
Because that's saying I need k cubed 4 times. If I have k cubed 4 times, this is not the actual rule, no. That's k to 12. So the actual rule is if you have a to the m to the n, what do you do with m and n? You multiply m times n.
Wait, what was the rule number 1?
I can't go back at the moment while they're writing. Times. Okay. Are we all caught up? So if I asked you to find for me 2p cubed, 2 to the 5th, all to the 6th, if I asked you to work that out, what do you do? My question is, do you do anything to the 2 if it's got that 6th power on the outside?
No, because you never change the base.
You never change the base. But technically that's really 2 to the 1st.
Is it?
So what should I do to the, am I adding these exponents or multiplying them? I'm multiplying them, and you have to multiply times that first. That 6 has to distribute to every term, so it does become 2 to the 6th, 2 to the 18th, and, yeah. And 2 to the 6th then is really 64. So yes, you have to distribute exponents onto numbers, even if it's just a base by itself, you still have to distribute to it. Alright, let's see if we can do one more problem before we have to cut a segment here. Oh, you're brilliant. I'm sure we can handle it.
You stop talking to the students on the video.
I stopped talking to the students on the video?
Yeah. That always made me feel good whenever I felt like you were talking to me.
Oh, okay.
Kept my attention better.
Okay, we're still talking to you guys. So, now that I have 1.5 minutes to get this problem accomplished, what should I do?
Write down the answer.
What do I do? Do I multiply them first, or do I do those powers on the outside first? Yeah, you gotta do the outside powers first, so that, now, so do I want to leave it as 2 cubed, or do I want to turn it to its number?
You want to keep it.
Are you going to be able to multiply 2 cubed times 3 squared over here? No, they're different bases. If they're different bases, work it out. If they're the same base, leave the base. So in this case, 2 cubed is really what? 8. R, yes. 2 to the 3rd, all right. And then this one, 9, and it will be a positive 9, r squared, to the 8th. There we go. And then, once you have those each done, now you can multiply them, and then what are you doing to your exponents? Now we're adding them. So we would have 72 r to the 8th, s, and t to the 11th. All right. And we'll stop this segment. We'll be back in a moment. Enjoy your commercial.